Okay, good day, sir. Kami po ang magre-report ng wind turbine. I'm Russell Jake Perido, Pauline Yambot, and Jan Christopher Gallardo. Next. Next slides. Yan yung picture ng wind turbine parts of operating principle. Ito yung paliwanag. Ito na yung close-up view ng wind turbine na nag-work na. Yan. As you can see, pag umikot yung blades, magsisimula na din gumalaw yung mga nozzles. Yung nozzle yung nasa yan. And then, because they are interconnected, kaya pag gumalaw na yung isa, gagalaw na din yung isa. From the blades rotation, susunod doon yung rotation na naman ng shaft and generators, yan na, yung mga parts niya. And then, tapos nasa likod na naman yung nozzle na triangle. Yun yung nandun sa likod. Mapapansin natin dito yung parang may triangle dyan sa likod. Yan. And also known as a wind vine. Ito naman yung nagde-detect ng wind direction. Then, yung 3 volts niya, ayun, yung yan. Rotating is the anemometer which is used to measure a wind. Yan yung mga gamit ng kung paano yung operating principle. Okay, next. Wind turbine operating principle. Wind turbine is a type of renewable energy that harnesses the power of wind to produce electricity. The basic idea is the wind turbine uses the rotator wind attached blades to collect wind's potential and kinetic energy. Wind turns with the blades which spins a shaft that is connected to a generator which results in a generation of electricity. A large number of wind turbines is usually called wind farm. Okay, next. Nandun naman na yung explanation niya kanina. Yan nga, yan na yung mga wind turbine. Yan na. Makikita natin yung yaw drive, yung motor, yan yung mga pinaka-importanteng parts natin. Isang pinaka-importanteng parts sa wind turbine. Pero, lahat ito ay kompleto and lahat naman ay importante. Sige, next. Dumako naman tayo sa blade. Wind turbine parts and function. Blade. The blade is a part of the rotates due to the force it catches from the wind. It is connected to the low speed shaft via the hub. The low speed shaft is connected to the gearbox and the gearbox to the generator. Once the blade rotates, it causes the rotation of generation, thereby generating electricity. Most wind turbine consists of 3 blades of maximum of efficiency. Yan. Ang kita natin dyan, yung kapag interconnected siya dito, yung nozzle niya. Nakikita yung nozzle, yan. Attached in the blade. Ma-touch yung blade niya, yan. It causes a rotate of all gearbox na kapag nag-rotate na yung blade, ro-rotate lahat yan. Lahat ng parts, kaya bubuo dyan ng energy. Okay? Next. Okay, yan na. Blade design. To produce an amount of power, wind turbine blades generally needs to be large and full. It is shaped to generate the maximum power from the wind at the minimum cost. Improvements in the design has produced new wind turbine which are more compact or quieter and generates more power from less wind. Its lengths vary at around 50 meters with 107 meters currently the longest from Siemens Gamesa. Yan naman yung blade design. Makikita man natin ito yung the longer, the better. Alangan naman, kung natin mas kapag maliit, kapangit naman yan. Hindi siya magpo-produce ng magandang electricity kapag konti yung blade design niya. Tapos, hinahanap naman dito yung cost of materials niya. Titingnan natin yung kung mahal pero maganda yung gawa nila, ganun. Yan yung tinitingnan ng mga engineers. Kung maganda yung mga klaseng design ng blades. Okay, next. Yan. Yung mga turbines na blade. Okay, next. Ayan. With turbine and parts and design. Oh, okay. Airfoils is the cross-sectional shape of the blade that determines its aerodynamics. They are key to blade design. This airfoil design allows the blade tips of a wind turbine to move faster than the wind is moving, thus generating more power and higher efficiencies. From the word airfoils. Airfoils is cross-sectional area. Yan yun, no? Yan. Yung gumagano, no? Dito. Yan. Yan yung cross-sectional area. And then, in a vital role in a aerodynamics. Kung from the word aerodynamics, the behavior of the winds, yan naman yung aerodynamics. Kasi para yung causes it rotate faster than the wind of velocity. Okay. Yan yung kanang airfoils and aerodynamics. Okay, next. Blade aerodynamics. Wind turbine blades work by generating two aerodynamic forces in the lift and drag. This is due to wind and their airfoils. Lift forces is a perpendicular to the airflow and it is in line with blade rotation. Drag force is in line with apparent with a direction, which is opposition of the blade motion. Drag increases in proportion to the frontal area of an object facing the wind. Yan. Kapag nag-collide yung hangin sa blade, may dalawang mabubuo. Yun yung tinatawag na lift and drag. Ang lift force ay yung perpendicular na wind direction. Nakikita naman natin yung perpendicular air direction. And the drag force ay naman ay yung in line with direction or a parallel. The drag force is yung ko-kontra sa hangin, ganun. Yung drag force. Okay, next. Oh, okay, yan po yung formula ng lift and drag. Pinapakita nila kung paano ito yung formula niya. Okay, next. Yan. Blade aerodynamics. Another thing that the airfoil is able to bring is for the blade to attain difference in pressure on the both sides. The most curved side, or we may say the convex side, generates low air pressure, while high pressure is pushes on the less curved side, or we may say the side with slightly concave varies. It is actually the reason for blade rotation. Drag, ito naman yung red. Makita naman natin yung red. Yan, yung red. As you can see, red. Merong, kapag tumama yung hangin, yung curve, yung sa taas, yan. Napupunta sila sa, it will become a low pressure. Yan, maglo-low pressure, yan. And then, yung nasa baba, yung nandun sa baba, mag-high pressure naman yun. Yan yung explanation niya kapag yun yung arrow. Yan. Okay. Next. Yan yung mga isang tanong na wind orientation. Here is now the question. Based on the figure illustrating optimum angle of attack. Okay. Which part of the blade is leading edge? The trailing edge from the end back. Ang tinatawag na angle of attack, ganyan yung tilted yan. Tilted na blade, yan yung pinaka the best. Kapag more cave sa taas, low curve yan na. Horizontal view of wind direction yan. Andi yan yung relative wind, yan yung sinasabi na horizontal view of wind direction. mas nakaharap yung less curve. Mas nakaharap yung less curve. Yan, yung lift, ganun yan nga. And then, mas mabilis ikot ng blade kapag. Mas mabilis kapag naka-curve yung ikot. Next. Thin air family, yan, airfoils design. Yan yung mga magkakaibang design ng airfoil design ng wind turbine. Madami siyang design. Pero, pare-parehas rin yan ng magkakaroon-produce ng electricity. Next. Rotation ng blade. Question, what will be rotation of the blade? It is pushed to the side that has more curve or pushed to the side that has less curve. Kapag yan yung tinanong nila sa inyo, paano i-explain yan? Sabi niya, madali lang yan. Kapag itinulak sa taas, o itutulak sa taas, less curve yan ng wind orientation. Tutulak lang, ganun lang yung explanation. Itutulak lang sa taas. So, less curve ng wind. Less curve. Okay, next. Wind turbine aerodynamics. Blade with wind orientation. The photo show the front and back side. Okay? Na-discuss naman na kanina yan. Sa pan. Okay, yan na. Blade design. In additional to its curve, design twisted and tapered blades further enhance its aerodynamics. With the combined effect of twisting and tapering the blade along its length improves the angle of attack, increasing speed, efficiency, and lift while reducing drag. It will increase the wind of rotation, madadagdagan yung lift force at mababawasan yung drag force. Yun lang naman yung pinaka-importante dun eh. Yung mababawasan, madadagdagan. Okay, next. Here is the question. Based on the previous slides, what number of blades is the best design is consideration of all the factors in construction and operation of wind turbine. Next. Yan, wind turbine number of blades. Yan yung mga quad. We already know that the rear of the blade is curved more than the front. The varied shape of causes a pressure differential when the air moves across the blade, which is what causes the blades to move. Because of the obstruction of the blade, air moves at a faster velocity behind the blade than in front of it. This is what sets the rotation of the blades in motion. Engineers must consider speed and drag designing the blades to ensure the highest level of efficiency. For example, if too much drag is created by the obstruction of the blade, the power yield will be a lot lower. Not enough drag is created, the blades could move too quickly, causing them break the sound barrier. Next. The rule of thumb are, first, the fewer blades, the better, since there were less drag, and the increases its efficiency, or the number of the blades increases the torque and reduces the optimum rotation speed, or heavy blades reduces torque. Yung sinasabi dyan yung pan. Kapag halimbawa sa pan, kapag yung maliit, kapag maliit yung pan mo, yung blade mo, maliit rin yung dagdag ng kuryente. Yung pan. And then, kapag madami yung blade mo na sinalpak mo, mas madami yung pumapasok na kuryente, mas mabigat, parang mas maganda. Parang kagaya sa kagaya ni Sir, yung sinabi ni Sir, yung halimbawa ng sprocket ng motor. Kapag sa likod, kapag malalaki yung ipin niya ng sprocket, mas yung hatak niya. Mas malakas. And then, kapag yung maliliit na sinalpak mo, yung ipin niya, ayun, mas hihina yung hatak niya, hindi makakatakbo. Yun yung example niya dyan. Parang yun yung pinaka-example niya. Yung blade. Okay, next. O, yan na nga, number of blades. Alangan na, matitignan naman natin, ma-analyze naman natin kung anong pinaka-the best na blade sa turbine sa wind. Siyempre, makikita natin yung tatlo. Pero ipapaliwanag natin na lang ng isa-isa kung bakit one blade, two blades, and three blades. And then, ito yung one. Because of the decreased drag, one blade would be the optimum number when it comes to energy yield. However, one blade could cause the turbine to become unbalanced, and this is not a practical choice for the stability of the turbine. Yun nga, hindi talaga maganda yung one blade. Yun yung pinaka-kwan talaga, acquired. Yan yung masasabi ko talaga na hindi parang hindi maganda, parang walang effect. Konti lang ang effect, gano'n. Okay? Next.
Yung sa two-blade naman. Yung sa two-blade, ano siya, perfectly balanced siya, pero may troubles sa yawing. So at first glance, ito na nga yan. Yung optimal configuration for a wind turbine. Perfectly balanced and with one blade less than a three-blade turbine, they will generate less drag. Kasi fewer the blade, lesser the drag. Okay. Yung nyo naman, ito yung when its head for nacelle turns to face the wind. Kunwari, di ba yung wind naman is hindi consistent kung saang direction manggagaling. Yung yaw, or madi-discuss yung mamaya sa yaw system. Yun yung yung parang paglipat-lipat nung mismong wind turbine. Next. Yung sa more than 3 blades naman. Any number of blades greater than 3 would create greater wind resistance, slowing the generation of electricity and thus become less efficient than a 3-blade turbine. Pag more than 3 blades naman, mas mabababa or bumabagal na yung generation of electricity kasi mas dumadami na yung blades na na-available. So yung pinaka-ideal na gamitin is yung 3-blade lang. Kasi these turbines designed with 3 blades are the ideal compromise between high energy yield and greater stability and durability of the turbine itself. Next. Ito na yung blade tilting mechanism. Yung sa blade tilting mechanism naman, ito yung wait lang. According to the wind spin, the relative velocity angle, ito yung angle nung mismong yung dito sa may rotor na to. Also changes. A blade tilting mechanism as a sensor coupled parts of the wind turbine which tilts the blades and guarantees a proper alignment of the blades with the relative velocity. So ito yung position is always at the optimum angle of attack. Kung saan manggagaling yung wind. Next is yung nacelle. Ito lang siya, yung pinaka-housing mismo. Ito. Yung part na to, yung lahat na yun nasa labas na. Next is yung gearbox. Yung gearbox naman, most of the time, hindi sapat yung ikot ng blades para fully maikot yung generator, di ba? Kasi minsan meron yung hangin mahina. Then mas mababa lang yung pag-rotate ng blades niya. Yung function ng gearbox, ito yung parang kino-convert niya yung, mas dinadagdagan niya. Pinabibilis niya pag dumaan na sa gearbox, mas bumibilis na yung rotation. Kaya pinabibilis para makaproduce ng grid quality na electricity. Most generators need to be turned out at 150 RPM and 180 RPM kasi in no way it is feasible for a turbine blade to move that fast. Hindi pa napapatunayan na gano'n na kaya nung blade na umikot ng gano'ng kabilis. So ito yung ratio ng gearbox, 90:1 with a rate 16.7 RPM input from the rotor to 1,500 RPM output for the generator. So yung yung sa ratio niya 90:1, pag nag-rotate ng isang yung blade, 90 times yung magiging ikot tong sa gearbox. Next is yung direct drive gearless. Ito naman yung ibang design. Yung, di ba na-mention kanina bakit merong gearbox? Di ba, nagpapabilis siya ng pag-ikot. So, meron ding mga design na gearless or yung walang gearbox. Kasi sa direct drive turbine, there is no gearbox. So, the main shaft spins the generator directly, causing it to spin at the same speed as the turbine blades. So, kung ano yung speed ng turbine blades, yun din yung speed na dumadating dun sa generator. Pero para maging possible to or yung pinagkaiba niya dun sa may gearbox is merong nadadagdag na mga magnets. Pero may disadvantage din siya. Ito yan. To make up for its slower rotation, more magnets are added and create the required frequency and power. This increases the diameter of the generator. So, mas lumalaki yung generator niya. Another thing is that the additional magnets being used in this type is made up of neodymium, which is expensive. So, mas mahal siya kasi mas mahal siya dun sa normal na may gearbox. The cost and weight of the direct drive turbines have prevented it from presenting major competition to the gearbox turbines until recently. But other experts claim that direct drive technology will eventually become the dominant one, since the gearbox wind turbine is almost at its maximum efficiency point, while the PMDD generators have more possibilities for improvements. So, nag-i-improve pa daw siya hanggang ngayon. So, next part is yung brake. The brake system in a wind turbine is a protective device coupled with sensors na automatic na nag-shutdown or nagpapahinto sa wind turbine pag sobrang lakas na yung hangin or merong mga parts yung wind turbine na hindi na nagpa-functions, na de-detect siya nung brake system. Next, ito na yung kanina yung yaw system na sinasabi. Ito is a sensor-equipped mechanism consisting primarily of yaw motor, yaw drives, and others. Its function is automatically rotates the nacelle on top of the tower so that the sets of blades is facing the wind directly at times. Kailangan, di ba yung sa wind turbine, kailangan lagi siya nakaharap dun sa wind para umikot siya. Ito yung yaw system, dito nangyayari yung paglipat-lipat ng direction ng wind turbine. Next part is the tower. Tower wind velocity increases at higher altitude. So yung sa tower naman, yung size niya is parang cone. Yung radius niya sa baba, pataas, mas lumiliit. Tapos sabi pa dito, yung usually 75 to 110 meters yung height ng mga towers. So yung tallest daw pero hindi pa siya complete na tower is 280 meters na to be installed at a test center in Western Jutland, Denmark. Ito nga yan. Ito compare lang natin dito yung wind turbine tower and diameter ratio. Makikita natin yung sa may 2000, 58 meters lang yung dito sa baba. Tapos yung sa rotor niya is 48. De mas mababa mas mataas yung height niya compare dito sa diameter ng rotor. Pero as time goes by, na-improve ng mga engineer or tapos sa pag-aaralan nila. Compare natin dito nung 2018 na mas mababa lang yung height niya. Pero mas malaki na yung diameter ng rotor or yung ikot na ng mga blades. So, yung wind turbine ideal location. So, sinasabi lang dito yung ideal location ng wind turbine is mostly sa mga coastal areas kasi mas malakas yung wind doon. Meron din sa mga hindi masyadong coastal pero konti lang sila. Kasi required nila is average wind speed of around 25 kilometers per hour. Ito naman yung advantages and disadvantages of wind turbine. Start natin sa advantages. Wind is free, libre nga naman siya. Tas di na kailangan ng fuel. Tas produces no waste or greenhouse gases. The land beneath can usually still be used for farming, a good method of supplying energy to remote areas. Next is the disadvantage. The wind is unpredictable. It changes speed throughout the day and from season to season. Then suitable areas for wind farms are often near the coastal area and where land is expensive. Thus can affect television reception on nearby places. Ito na yung mga largest wind farm. First, nanguna dito is yung sa China, Gansu Wind Farm, having 7,965 capacity niya. Thus, next doon is sa California, USA, the Alta Wind Energy Center. Next is India, Mupandal Wind Farm. The next one is in UK, Hornsea Project 1. Sumunod doon yung Sweden, Mark Bygden Wind Farm. Last yung pang 6 ba? Yes, sa India ulit. Jaisalmer Wind Farm. Ito yung sa Philippines. May wind farm tayo located sa Burgos, Ilocos Norte. 150 MW Burgos Wind Farm is the largest wind project in Southeast Asia. So, siya yung largest wind power dito sa atin sa Southeast Asia. Estimated cost for the construction ng wind farm is $450 million. Nung nakompleto siya noong 2015. Located with 600 hectare site. The facility consists of 50 wind turbines, each with the capacity of 3 MW, generating electricity to the Luzon grid. Thus, each wind turbine rests on a tubular steel tower has a 75-meter hub height and 90 rotor diameter. So, ito na yung summary lang siya ng picture. Diba, ito na yung sa wind, tapos iikot na yung blades, iikot na din tong nandito sa mga shaft, gearbox, papunta sa generator. Tapos, pupunta na dito tapos nakakonect siya sa transformer para yung mangyayari naman sa transformer is mag-step up, tapos diretso na sa mga green lights, tapos diretso na sa atin.
Okay, this is the last topic for today. This is the hydrogen power plant, and I'm John Christopher C. Gallardo, and I'm the one to present this topic. Next. Description. A hydrogen power plant is a concept designed for a new widespread source of electricity. Essentially, it is a facility which uses hydrogen to produce electrical energy. Ngayon, yung hydrogen, this is a new source of electricity. Then the hydrogen used to be sourced is pure hydrogen. Hindi pwede siyang combination. Dapat pure na hydrogen siya. Next. Okay, the working principle of hydrogen power plant. Then the main part in the hydrogen power plant is the hydrogen fuel cells. And the working principle of fuel cells is same on how batteries working. Well, if you want to know the principle on how hydrogen fuel cells are working on the power plant, we need to dissect the parts of battery because the working principle of hydrogen fuel cells and a battery is the same. Well, this working principle, napakahaba po nito, pero madidiscuss po natin to sa schematic diagram. Next.
Well, this is the battery parts and function. Pangauna dito is the electrolyte. The electrolyte is a chemical compound that conducts electricity by changing into ions when melted or dissolved into a solution. It can be a liquid or paste-like substance. Example of this is ammonium chloride, zinc chloride, potassium hydroxide. Then anode is the negative or reducing electrode. Then the last is the cathode, is the positive or exciting electrode that acquires electrons from the external circuit and is reduced during the electrochemical reaction. Next. This is the battery schematic diagram. Katulad nga sinabi ko sa una, kailangan natin i-dissect yung battery para malaman natin kung paano siya talaga gumagana. Ngayon, on this diagram, nakikita natin yung anode and cathode are submerged on the electrolyte solution. Ngayon, pero hindi nyo nakikita, meron siyang nakalagay doon sa middle of it, yung siya nagdi-divide sa anode and cathode. And ang tawag dito is semi-permeable barrier. Wala siya dito sa pictures, dito sa diagram. Pero ang nasa gitna niya is semi-permeable barrier. Then, when the anode submerged on electrolyte, they produce excess of electron because of chemical reaction. Well, the result of excess of electron, they repel each other. Kasi, di ba, puro electrons sila, kaya nagre-repel sila. Ngayon, sa pagdami ng electron, may iba na gustong pumunta sa kakaunting electron lang. Ngayon, para sa kakaunting electron, punta tayo sa cathode. Ngayon, when the cathode submerge on electrolyte, produce electron acceptor. Kasi sa chemical reaction nila. Ngayon, yung makikita nyong line na yan yung wire connected into anode and cathode. Ngayon, dyan pag yung anode kasi nag-excess siya ng electron, yung electron na excess, dyan siya travel papunta sa cathode. Kasi yung cathode ngayon, pag nag-submerge siya sa electrolyte, magiging magiging electron acceptor siya. Ngayon, that's it. That is the working principle of batteries. Yun na yun. Kaya yung pag sa hydrogen, green din ang kinalabasan yan. Next. Well, this is the parts of battery construction. Makikita nyo dito yung anode, cathode, and electrolyte na ginagamit. Pero ang ginagamit dito is the materials nga lang. Next. How it works. The battery, how it works. Well, nasabi ko na doon sa schematic diagram niya na kapag yung anode is submerged on the electrolyte, magkaroon siya ng excess electron. Then the excess electron travel to cathode kasi kapag yung cathode is submerged on the electrolyte, ang chemical reaction niya is electron acceptor. Okay, next. Chemical reaction in zinc-carbon battery. Well, di ba iba-iba yung mga materials na ginagamit sa battery? Pag iba-iba yung materials na ginagamit sa battery, iba-iba rin yung chemical reaction. Pero same principle pa rin sila. Katulad dito sa chemical reaction in zinc-carbon battery. Pero hindi tayo dito magpo-focus. Mag-focus tayo sa hydrogen. Kinuha lang natin dito yung principle niya. Next. Next po. Yan. This is the working principle of hydrogen fuel cell. Ngayon, di ba sa battery nga, meron siyang anode and cathode. Ngayon, yung hydrogen, siya yung magsusupply doon sa anode. And Yung oxygen naman, siya yung nagsusupply doon sa cathode. Well, when the molecules of a hydrogen reacts on the catalyst made up of platinum, ngayon pag yung molecule ng hydrogen react doon sa catalyst na made of platinum, the molecule is split on two, the proton and the electron. Ngayon, these two particles are heading towards to cathode. Ngayon, sa gitna nila, may tinatawag na proton exchange membrane. Ibig sabihin, yung proton lang kayang mag-bypass doon sa gitna. At yung electron naman, siya yung binablock ng membrane. Ngayon, paano pupunta yung electron sa cathode? May makikita kayong connecting wire doon sa dalawa na yun. Tapos yung electron, doon siya magta-travel. Ngayon, kapag yung electron nakapag-travel na papuntang cathode, tapos yung proton, nag-bypass na doon sa proton exchange membrane, ngayon mag-unite siya. Katapos mag-unite, yung oxygen naman, tawag dito, yung united of proton and electron combined with oxygen thanks to the aid of catalyst. Ngayon, the byproduct of this is water vapor or the water. Then the output is direct current katulad sa battery. Next. This is how fuel cell vehicle works. Parang same lang din siya dun sa schematic na pinakita earlier. Next. Hydrogen fuel cell working principle. This is the detailed of how hydrogen fuel cell working on a hydrogen power plant. Well, this is the detail. Then, well, earlier I summarized of it. Pero kung gusto niyo malinawan pa, ito yung pinaka-detail niya. Pero yung yung mga sinabi ko sa schematic diagram, malinaw din po siya. Napakalinaw po na sinabi ko nun at napaka-konti lang po. Maiintindihan nyo kagad yun. Next. This is the hydrogen fuel cell working principle or the summary of hydrogen fuel cell. Next po. This is the part of hydrogen power plant. Ngayon, makikita natin yung dalawang tank na contains of hydrogen and oxygen. Ngayon, alam natin yung hydrogen supply on the anode and the oxygen supply on the cathode. Ngayon, sa isang power plant, 1,000 of hydrogen fuel cells ang kailangan upang mapag-operate ng isang power plant ng hydrogen. Then, di ko na yung explain yung kanyang proseso kasi na-explain ko na yung byproduct ng hydrogen na ito. Pabalik ko sa yan. Yung byproduct of this is the water and water vapor. Ngayon yung outcome or output of this power plant is DC. Well, when it comes to DC, we need a inverter to convert DC to AC. Kaya pag nakapag-convert na AC, we need a step-up transformer because we have to avoid further losses due to very long transition line in the power grid and then connect it to the substation. Next block. Well, why explore it? Ba't natin i-explore yung hydrogen? Ito, hydrogen is a very efficient fuel source capable of producing more energy per pound of fuel than gasoline. Ba't sinasabing efficient? Let me give a example of this. Well, there are cars that powered by hydrogen and gasoline. Tama, di ba? The difference of this is the efficient of it. Well, when it comes to travel by a car powered by hydrogen, they are long last than the gasoline. Okay, isang advantage siya ng hydrogen, yung efficiency niya. Efficiency. On the second one advantage of hydrogen is the emission of it. Hydrogen have a low emission because the byproduct of this is the water and the water vapor. Ngayon, yung byproduct ng combustion engine emits a carbon dioxide na pwedeng makasira ng ating ozone layer. And the third advantage of hydrogen fuel cells is the hydrogen fuel cells is quiet during operation, lalo na sa mga kotse. Next po. Why it hasn't gone mainstream? Well, hydrogen production through methane. Ngayon kasi, kapag na-extract ka ng hydrogen to methane, magamit tayo ng carbon, nagkaroon tayo ng byproduct na carbon dioxide na pwedeng makasira sa ozone layer. Di ba ang mission natin is low emission. Ngayon, kapag nag-extract tayo sa methane ng hydrogen, ang byproduct nito is carbon dioxide. Well, hydrogen production through water. The other production method is electrolysis, which separates hydrogen from water. Well, pag separate ka ng hydrogen through the water, napaka-expensive ng mga gamit na gagamitin mo dito gagamitin mo upang ma-separate yung hydrogen sa water. The cost of fuel cells can be high given the use of platinum as one of the largest component materials. However, there is work underway to find non-platinum catalyst approaches. Kasi yung cost ng platinum is napakalaki. Maabot siya ng million din or basta maabot siya ng ganun mga million yung platinum kasi ay napakamahal. Next po.
Boss, wait lang. Susunduin ko lang nanay ko.
Okay. Hydrogen storage. Scientists are still struggling with the challenge of how to store hydrogen because it has such a low energy density. Hydrogen needs to be kept under strong compression to be a viable fuel source. Ngayon kasi wala pang nabibuild na storage for hydrogen. Kung meron man, dry run pa lang ito. Dry run pa lang siya. Ngayon, hydrogen leak. Hydrogen leakage can occur during many steps of its production and use. Science magazine reported in June 2003 that hydrogen leakage, use of hydrogen fuel would gobble up ozone faster than CFCs do. Pag nagkaroon ng hydrogen leak, mas mabilis matutunaw yung ating ozone layer kaysa sa CFC. Next. This is the latest development of hydrogen power plant pero dry run pa rin po siya. Hindi pa masyadong bukas talaga yung latest development ng hydrogen power plant. Long-range energy generation project of touted as a first of its kind power plant in the United States. The long-range energy generation project, a 485 megawatts facility being equipped to run on a mix of natural gas and carbon-free hydrogen, is nearing completion at the site of a former aluminum smelter on the bank of the Ohio River. Ngayon, the facility first will burn a fuel blend that includes 5% of hydrogen dun sa long-range energy generation project. Ngayon, the plant is intended to transition to 100%. Pero sinasabi ko nga, dry run pa rin ito. Hindi siya ito ganun kabukas talaga. Dry run pa lang. 100% green hydrogen over the next decade by relying increasingly on renewable energy to power electrolysis machines that split water into its hydrogen and oxygen elements. Next. Siemens Energy. Construction begins on world's largest green hydrogen power plant, part of unique baseload solar project. Siemens Energy will operate the unique Euro 170 million euro facility in a remote part of French Guiana, which will provide a IOMW of power during the day and 3 megawatts at night, which will provide 10 megawatts pala yun, 10 megawatts. Then, a unique base load renewable project that combines the world's largest hydrogen power plant, which a 16 megawatts machine for electrolysis of water, a 3 megawatts fuel cell, 55 megawatts of solar panels, and 20 to 38 megawatts of batteries has begun construction in French Guiana, Collins 2021. Okay, that's it. This is the last part of our topic. And thank you for listening. Goodbye.
Thank you po.